Good morning, student. I am welcoming you to my YouTube channel, Learning Hygiene. Today, I am going to share with you a small video with MCQs from Chapter 2, Class 12 Physics. In my earlier video, you can get the relative or very important MCQs which are very relevant for your monthly exam. So go through my earlier video also. The link is given in the description. Let us start without any delay. Okay, so the first question is 100 joule of work is performed in carrying a charge of 5 coulombs from infinity to a particular point in an uniform electrostatic field. The potential of this point is, potential means you will have to find out the voltage difference. That is voltage. So here the options are 100 volt, 5 volt, minus 20 volt, 20 volt. What would be the answer? So I'm showing you how see we know that W, that is work done, equal to QV, that is Q into voltage. We know that चार्ज को अगर वोल्टेज से मल्टीप्लाई करते हो तो वोल्टेज मीन्स पोटेंशियल डिफरेंस, तो आपको आता है वर्क डन. यहाँ पे तो वर्क डन दिया हुआ है कितना 100 जूल. तो पुट दिस वैल्यू इन प्लेस ऑफ W, so 100, and Q. What is the value of Q here? Minus 5 coulomb. So put minus 5 here into V. This is the potential difference. So we will get potential difference very easily. 100 by minus 5. It is minus 20 volt. So it is very easy. So the answer would be, you see, answer would be minus 20 volt. Okay. Now next question. 3 different capacitors are connected in series. Then they will have equal charge. They will have same potential. Both 1 and 2. None of this. क्या होगा? अगर 3 कैपेसिटर को different value, 3 different capacitors are connected in series, then they will have equal charge. They will have same potential. Both 1 and 2. What is the correct answer? See, I'm explaining you. That's why video may be a little bit long. Please bear with me. See, this is a capacitor. If we connect another capacitor in series, another in series, okay, and connected with a voltage. So voltage D, capacitor C1, C2, C3. They have different capacities. So you know, if it is in series, in case of capacitance, capacitor, the charge Q, charge flow through this remain same. So the answer would be, because if the circuit or the combination had it been in a parallel, then the voltage would have been same. But in case of series, इसमें चार्ज सेम रहता है, ये याद रखने का. Okay, now see the answer. Answer is already mentioned here. So they will have equal charge. Now go to the question number 3. A hollow metal sphere of radius 10 centimeter is charged such that the potential on its surface is 80 volt. The potential at the center of the sphere is. The question is very much interesting. The options are this. So what would be the answer over here? You see, a hollow sphere, that is अंदर में कुछ नहीं है, hollow metal sphere है, like this. This is sphere. So the radius is 10 centimeter. The potential such that the potential on its surface is 80 volt. Here in the surface the potential is 80 volt. Now the potential at the center of the sphere is, see, as it is a hollow sphere. So in case of hollow sphere, you see the voltage, if you go inside, there is no electric field, but voltage always remain same. Whatever any hollow sphere, metal sphere, the charges will lie on the surface. So the potential here always remains same inside the whole hollow space. Inside the whole empty space, there is no charge, and the potential difference would be 80. That means equal to the potential inside a hollow sphere, hollow thing. The potential remain fixed as on the surface. So answer would be 80. Answer would be 80. 80 volt. Is it clear? See, hollow sphere का metal sphere का केस में चार्ज रहता है सरफेस में, एंड इलेक्ट्रिक फील्ड होगा सरफेस में, बट इनसाइड में कोई इलेक्ट्रिक फील्ड नहीं है, बट इनसाइड में वोल्टेज या पोटेंशियल डिफरेंस सेम रहता है एज पर एज ऑन द सरफेस. होप इट इज क्लियर. नाउ गो टू द नेक्स्ट क्वेश्चन. Let us set up this. Okay, now the question is, the capacitance of a capacitor will decrease if we introduce a slab of copper, aluminum, zinc. Yeah, none of this. It is very easy because we should insert dielectric material, not the metal, to increase the capacitance of the capacitor. Now here it is not the metal, all of the metal. The capacitance of a capacitor will decrease. इसमें decrease नहीं होगा, okay, because all are the metals, right? No effect. Now question number 5. Two capacitor of capacitance 6 microfarad and 4 microfarad are put in series across a 120 voltage battery. What is the potential difference across the 4 microfarad capacitor? Let us draw this picture. Drawing here, like this. Two capacitors. So this is one capacitor. They're put in series, so it will be in the same line, and they have been connected with 120 voltage battery. So this is 6 microfarad and this is 4 microfarad. क्वेश्चन क्या है? क्वेश्चन है कि ये जो 4 माइक्रोफैराड कैपेसिटर है, इसके अक्रॉस व्हाट इज द पोटेंशियल डिफरेंस हियर? V कितना है यहाँ पे तो सपोज हियर इज V1, that is V2. So what is the value of V2 against this 4 ohm 4 microfarad resistance? Now how the calculation will be done? See here, as it is in series connection, so the charge here is Q, then here also to be Q. So charge is constant. Now if charge is constant, then how do you find out the voltage against this? First of all, find out the charge. ये Q charge कितना है? It is as simple as like a series connection in case of resistance. हम वहाँ पे क्या करते हैं? To find out the voltage against any resistance, we find out the equivalent resistance and find out the current flow through it. यहाँ पे भी हम ऐसे करेंगे. Q is equivalent to current in case of resistance. So यहाँ पे करंट निकालने के लिए मेरे को इक्विवेलेंट, ये जो दो कैपेसिटर सीरीज में कनेक्टेड है तो उसका इक्विवेलेंट कैपेसिटेंस निकालना है. कैसे? सीरीज का केस में ऐसे होता है कैपेसिटेंस. सपोज दिस इज द इक्विवेलेंट resultant capacitance equal to 1 by C1 plus 1 by C2. So here 1 by 6 plus 1 by 4. Upon calculation, CR is coming, C equivalent or C resultant is coming 2.4 microfarad. Okay, now again I know C Q equal to C into V. If it is V2, you can put V2, it is C2. So Q I have got 2.4 and C2 I know 4 into V2 I don't know. So from here I can get V2 equal to 2.4 by 4. So it is coming 0.6. Okay. Now one more thing. Here you see this is microfarad. You should convert it into farad. So this will be multiplied by 10 to the power minus 6. So here it is 10 to the power minus 6. So it will be what the value would be. This is Q. V1. Mm. 120 volt is okay. 6Q. I'm getting Q. Just a minute. I'm just erasing this one. You see, B is 120. So equivalent resistance is this. So Q equal to CR into 120. So this will come 2.4 into 120 coulomb. Okay. So this is multiplied by 10 to the power minus 6 farad. So keep it here. Now you get Q. But this is the Q. This is the Q. So to find out the voltage against this, now we will again apply Q equal to C 2 V2. So Q is equal to 2.4 into 10 to the power minus 6 into 120 into V2. So V2 would be Q is 4 point, कुछ 4 माइक्रोफैराड का इलेक्ट्रिक बोला है ना, 4 into 10 to the power minus 6 divided by 2.4 into 120. If you find out the value here, you will get 400 over 6. This is the Q into 10 to the power minus 6. So it will be 72 volt. Okay, hope it is clear to you. If you have any question, you can mark this in feedback column. Okay, so this is 72 voltage. I hope it is clear. We find out the equivalent capacitance. उसके बाद हमने इसका ये जो Q है, ये Q कितना है वो निकाल दिया ना कूलम. Then again we use Q equal to C2B2 for this, for 4 microfarad capacitance. Then we find out this. Okay, hope it is clear to you. Then proceed for the second question. See, this is the answer. Now let us do one thing. First of all, delete these. So now the question number 6. In which of the following form is the energy stored in a capacitor? एक कैपेसिटर में एनर्जी कैसे स्टोर होता है? या चार्ज के हिसाब में, पोटेंशियल के हिसाब में, या कैपेसिटेंस, या इलेक्ट्रिक फील्ड? आंसर इज पोटेंशियल. ओके, पोटेंशियल एनर्जी के हिसाब से इसमें स्टोर होता है एनर्जी. ओके, नाउ कम टू द क्वेश्चन नंबर 7. A bird sitting on a high power line gets killed instantly, gets a mild shock, gets a fatal shock, is not affected practically. कौन सा आंसर होगा? पक्षी अगर एक हाई वोल्टेज लाइन में बैठता है, where there is a high potential, हाई टेंशन लाइन, तो उसको क्या होगा? कुछ होगा या मर जाएगा? क्या होगा? ये कुछ नहीं होगा. इज नॉट अफेक्टेड प्रैक्टिकली, क्योंकि व्हेन ए बर्ड इज, जो यहाँ पे लिखा हुआ है, यहाँ पे सर्किट क्लोज नहीं होते हैं. जो बैठता है ना, ये इट इज नॉट गेटिंग अर्थ. तो जब सर्किट क्लोज नहीं होगा ना, तब कुछ इफेक्ट नहीं होगा. ठीक है, आई थिंक इट इज clear to you. Go to the next question. The electric potential of earth is taken as you know, it is 0. So no need to explain. Go to the next question. Minimum number of capacitors of 2 microfarad each required to obtain a capacitance of 5 microfarad will be. इसका मतलब कितना चाहिए, कितना कैपेसिटर 2 ओम का लगाने से आपको 5 ओम 5 सॉरी नॉट ओम माइक्रोफेराड 2 माइक्रोफेराड का कितना कैपेसिटर आप कॉम्बिनेशन करोगे तो आपको 5 माइक्रोफेराड मिलेगा कैपेसिटेंस. So let us understand this. Okay, capacitor, I don't know, I can combine capacitor in series, I can combine capacitor in parallel, I can combine capacitor in all in series or in parallel. किसी भी तरीके से आप कॉम्बिनेशन कंबाइन करो, बट इसके इक्विवेलेंट कैपेसिटेंस 5 माइक्रोफेराड होना चाहिए. जो कैपेसिटर लगाओगे उसका वैल्यू है 2 माइक्रोफेराड ईच. 2 माइक्रोफेराड 2 माइक्रोफेराड 2 माइक्रोफेराड 2 माइक्रोफेराड. तो कैसे लगाओगे, ये है. इसका सॉल्यूशन करने के लिए आपको ट्रायल एंड एरर मेथड अप्लाई करना पड़ेगा. पहले इसको जोड़ के देखोगे होता है क्या नहीं, फिर उसको जोड़ोगे ये होता है क्या नहीं. देखो ये अगर 2 है तो सीरीज में होता है तो क्या होता है, सीरीज में होता है तो इक्विवेलेंट होता है ऐसे, सी इक्विवेलेंट इक्वल टू 1/2 प्लस 1/2. This will be 2/2 equal to 1. And here also same case, the combination of these two would be 1. So, and again they are in parallel, so it would be 2. So 5 तो हुआ नहीं, 5 नहीं हुआ. तो कैसे करेंगे हम, let us second try. Suppose 1 is in here and second there is 2, put 2 here in series and 1 again in parallel. Now connect them in with better. So it is 2, it is 2, it is 2, it is 2. These two are in series, so the equivalent would be 1. And again these and combination of these and combination of these are in parallel. So ये sum हो जाएगा. So 2 plus 1 plus 2 हो गया 5. 2 plus 1 plus 2 हो गया 5. So we need 4 number of capacitance with value 2 microfarad, and connection would be like this. Connection would be like this, and doing finally this. Yes, this will be the combination. 2, 2, 2, 2, that 4, and the equivalent would be 5. Hope this is clear to you. So let us see the answer. Answer would be 4. So this is the 4. Let's go to the next question. A capacitor is charged and battery is disconnected. Now the distance between the plates is increased slightly. See, ये करने से क्या होगा, force between the plates will decrease, the potential energy of the capacitor will decrease, potential difference between the plates will decrease, potential difference between the plates will increase. क्या होगा, ये बहुत ही इंपॉर्टेंट एक क्वेश्चन है. इसमें होता क्या है, सी you know, I'm explaining it to you, just remain with me. If this is a capacitor, okay, we know if it is connected with a battery, suppose voltage potential V, and the capacity is C. Now the distance between the plates, a capacitor is charged with a battery. Suppose it is charged Q charge, and after that it has been disconnected. So if you disconnect this, it will be like this, C and Q will be there. Now distance between the plates increased. पहले सपोज डिस्टेंस था D, अब इसको डिस्टेंस बढ़ा दिया, तो इसमें क्या हुआ, चार्ज तो सही रहता है क्योंकि अभी बैटरी अपना हटा दिया, जितना चार्ज था उतना चार्ज तो है, एंड इसका कैपेसिटेंस क्या होगा, कैपेसिटेंस ये डिस्टेंस अपने बढ़ा दिया तो कैपेसिटेंस थोड़ा घट जाएगा, क्योंकि कैपेसिटेंस का फॉर्मूला होता है एप्सिलॉन ए बाई डी। सो ये प्लेट तो सेम रहा, अपने डिस्टेंस बढ़ा दिया, दिस इज द डिस्टेंस, सो ये कैपेसिटेंस घट जाएगा, क्यू सेम रहेगा, ओके। एंड यहाँ पे देखो तो फिर क्या हुआ, फर्स्ट पॉइंट, फोर्स बिटवीन द प्लेट विल डिक्रीज, फोर्स मींस इलेक्ट्रोस्टैटिक फोर्स, ये अभी नहीं होगा, फोर्स तो डिक्रीज नहीं होगा कि इलेक्ट्रिक फील्ड सेम रहेगा, पे इलेक्ट्रिक फील्ड सेम रहेगा तो फोर्स, ओके। कैपेसिटेंस विल, फोर्स बिटवीन द प्लेट विल डिक्रीज, डिक्रीज नहीं होगा, ओके। अच्छा, बिकॉज ये सेम रहेगा इलेक्ट्रिक फील्ड, द पोटेंशियल एनर्जी ऑफ द कैपेसिटर विल डिक्रीज, पोटेंशियल एनर्जी ऑफ द कैपेसिटर, पोटेंशियल एनर्जी कैसे होगा, पोटेंशियल एनर्जी तो इसमें तो आपने अप्लाई किया था पोटेंशियल एनर्जी, तो पोटेंशियल एनर्जी ऑफ द कैपेसिटर डिक्रीज, नहीं, ये तो फिक्स करके दिया था आपने, तो ये भी डिक्रीज नहीं होगा। नाउ हाउ टू कैलकुलेट दिस, सी एनर्जी, potential energy equal to, we know there's a formula, q square by c. Here q square is fixed, but c decreases. So what happened? Q square by c. Q is constant because no supply is there right now, and the plate separation of capacitor. Go to the question again. A capacitor is charged and battery is disconnected. Now the distance between the plate is increased slightly. Potential energy stored will decrease. Just on it. The potential difference between the plates will increase. How? This is the answer. Just a minute. Just a minute. Notation is one. See, the second point is the potential energy of the capacitor will decrease. Here you see, C q square is same and C is decreasing. If C decrease, then the value will increase, but here it is mentioned decrease. So this answer would be cross. This is cross, this is cross. Now potential difference between the plate will decrease. Yes, we know Q equal to CD. So C is going to decrease. So potential difference will increase. Potential difference between the plate will be going to increase, but here it is mentioned decrease. So this is also not happening. Here, potential difference between the plate will increase. It is correct. So hope it is clear to you. I am again explaining you. Just bear with me. इसमें क्या बोला था कि एक वोल्टेज अप्लाई किया था एक कैपेसिटर में. सो ये चार्ज करने के बाद इसको बैटरी को सेपरेट कर दिया गया. ये ओनली कैपेसिटर रख दिया. अभी इसमें जब ये बैटरी को हटा दिया गया तब इसमें जितना चार्ज होना था हो गया. तो ये चार्ज अभी फिक्स्ड हो गया. चार्ज इज फिक्स्ड एंड कैपेसिटर का कैपेसिटेंस तो वो भी फिक्स्ड है. बट अभी क्या किया उसका डिस्टेंस बढ़ा दिया. तो डिस्टेंस बढ़ा दिया मतलब हम जानते हैं कोई भी कैपेसिटेंस इक्वल टू होता है ये फॉर्मूला एप्सिलॉन नॉट ए बाई डी. यार ए होता है उसका एरिया ऑफ द क्रॉस सेक्शन एरिया ऑफ द प्लेट यूज्ड एंड डी होता है इसका डिस्टेंस बिटवीन द प्लेट्स. अगर डिस्टेंस बढ़ा दिया गया एरिया तो फिक्स्ड है ये भी फिक्स्ड है. सो डेफिनेटली डिनोमिनेटर में ये बढ़ गया तो सी डाउन हो जाएगा. तो सी कम हो जाएगा इस कैपेसिटर का. तो यहाँ पे जो और चार्ज क्यू है तो इसके अंदर जो इलेक्ट्रिक फील्ड है ना वो भी सेम रहेगा बट ये भी बोला डिक्रीज हो जाएगा. तो इसीलिए पहले वाला कैंसिल. तो पोटेंशियल एनर्जी ऑफ द कैपेसिटर विल डिक्रीज बोला बट ये भी हमने देखा ये इंक्रीज होगा क्योंकि क्यू सेम क्यू स्क्वायर सेम एंड सी डिक्रीज तो ये इंक्रीज होना चाहिए और ये बोला डिक्रीज होगा तो ये कैंसिल. सी में क्या ऑप्शन सी में बोला इसका पोटेंशियल डिफरेंस डिक्रीज होगा बट हमने देखा ये इंक्रीज होगा क्योंकि यहाँ पे सी डिक्रीज होगा क्यू कांस्टेंट डेफिनेटली बी इंक्रीज होगा. तो द फोर्थ वाला ऑप्शन इज करेक्ट. I hope it is clear to you. I am explaining you very slowly so that you can understand this. That's why video will be a little bit lengthy. Please bear with me. A capacitor is connected across a battery and the plate separation of the capacitor is increased without removing the battery. See, these two questions are very, very relevant for your upcoming exam. You will get either one question between these two questions. पहले वाला में क्या हुआ था चार्ज करने के बाद बैटरी को हटा दिया गया था. अब इसमें क्या किया इसमें बैटरी को हटाया. इसमें a capacitor is connected across a battery and the plate separation of the capacitor is increased without removing the battery. अब क्या किया suppose this is a capacitor and it is connected with the battery. So voltage V and this is capacitor. It has been charged suppose Q. Now battery is not separated. What is done? The space between them is increased. Battery is there. Battery is there connected. So here you see as the distance increased, that is D increased, so the capacitance C will decrease. C will decrease, but Q here you see the voltage battery connected, so voltage remain constant. Here voltage equal to constant. 2 point remind very try to keep remember these 2 points. If battery is remain connected then voltage remain constant. If battery is separated then Q remain constant. Here Q is not constant, here V is constant. So क्या होगा यहाँ पे कैपेसिटेंस विल इंक्रीज. नो कैपेसिटेंस तो डिक्रीज होगा क्योंकि ये डिस्टेंस इंक्रीज हुआ. चार्ज स्टोर विल इंक्रीज. चार्ज स्टोर विल increase. This possibility is there. Let us check. Energy store will increase. Energy stores. Energy का क्या फॉर्मूला है पहले बार लिखा था यहाँ पे. एनर्जी का फॉर्मूला है U इक्वल टू Q स्क्वायर बाय 2C. This is the formula for not 2C, Q square by C. This is the energy formula. Now C is decreasing, obviously C decreasing, तो Q square increase होगा, तो एनर्जी स्टोर विल बी इंक्रीज, तो करेक्ट है. पोटेंशियल डिफरेंस विल इंक्रीज, पोटेंशियल डिफरेंस इंक्रीज नहीं होगा, ये तो फिक्स्ड रहेगा. चार्ज स्टोर विल इंक्रीज, चार्ज स्टोर इंक्रीज होगा क्या, देखो Q equal to CB, here C is getting decreased, V is constant, C is decreasing, V is constant, so if C decrease then Q will also decrease, but here charge will increase also, it is also not correct. Now let us see the answer. So एक ही आंसर बचा हुआ है, that is energy store will increase. I hope it is clear. So these two questions are very important. This page is very important for the coming exam. Now let us go to the next question. Okay, to start for the next questions. I hope you are this video will helpful for you. So please bear with me. I'm again telling you because I'm going very slowly with the explanation of all the questions with their answers. When a dielectric slab is introduced between the plates of a parallel plate capacitor, which remain connected to a battery, then charge on the plates relative to the earliest charge is more, less, maybe more. You see, yeah, इसमें हमने देखो, मैं ड्राइंग करके दिखाता हूँ. Suppose this is a capacitor and I have connected this with this battery. If the capacitance is C, so Q equal to CB, we know that. Now अगर एक डाइलेक्ट्रिक स्टेप को बीच में इंसर्ट कर लेते हैं, तो हम जानते हैं कि डाइलेक्ट्रिक जब इंसर्ट होता है तब कैपेसिटेंस डाइलेक्ट्रिक कांस्टेंट का साथ मल्टीप्लाई होके इतना, ये सी फाइनल सी डैश टू बी के इनटू सी. दैट मींस अगर कोई डाइलेक्ट्रिक मटेरियल अंदर में इंसर्ट होते हैं, ऐसे डाइलेक्ट्रिक मटेरियल, दिस इज द कैपेसिटर प्लेट. Okay, capacitor plate is there. In between we have inserted a dielectric material, that is insulator. तो insulator का एक होता है डाइलेक्ट्रिक कांस्टेंट के, तो इधर का जो कैपेसिटर है उसका कैपेसिटेंस के टाइम्स बढ़ जाता है. व्हाट इज के? के इज द डाइलेक्ट्रिक कांस्टेंट. सो द न्यू कैपेसिटेंस विल बी के इनटू सी, दैट मींस इंक्रीज हो गया. अब फिर Q इक्वल टू वी नो सी भी, तो C increased means this value increased, that means Q increased. So the plate, the charge would be more. I think it is clear to you. So let us go to the next question. The radius of two metallic spheres A and B are R1 R2 respectively. Okay, the radius is given R1 R2 respectively. So here R1 is greater than R2. They are connected by a thin wire and a system is given certain charges. The charge will be greater. Now the charge will be greater for which? See the options. I'm giving you the options first, then you will find it out. These are the options. So now I am explaining you. You can guess what is the answer. Now what is the conditions? That there is a sphere, smaller sphere, and a smaller sphere. Here R1. So this will be R1. R1 is greater than R2. R1 greater than R2. So this is the bigger circle. This is the bigger sphere. This is the smaller sphere. Now step by step, go step by step. They are connected by a thin wire, and a system is given a सर्टेन चार्ज, ये एक वायर से कनेक्ट कर दिया, तो चार्ज इंडिकेटर, अभी इसमें चार्ज दिया हुआ है, चार्ज अगर दिया हुआ है, सपोज चार्ज सप्लाई किया उसमें, तो दोनों कनेक्टेड है, तो चार्ज तो शेयर होंगे। अभी चार्ज किसमें ज्यादा होगा, देखो चार्ज के लिए एक फॉर्मूला है, चार्ज वो नो ये कि चार्ज डिपेंड करता है, चार्ज इज इनवर्सली प्रोपोर्शनल टू its r1 radius, okay, so एक फॉर्मूला है q by r, q by r remain constant, so q1 by r1 would be q2 by r2, okay, so if here r1 is greater, so this value will be smaller, r2 is smaller, so this value will be charge. See, if these two are equal, then definitely if this is bigger, this should be bigger. If this is smaller, this should be smaller, because to maintain the ratio equal, so Q1 would be greater than Q2. So here Q1 would be greater than Q2. Hope it is clear to you. So now let us go to the answer. On the surface of the sphere A would be greater. Okay. Now let us delete this. Now next question. For a uniform electric field, E equal to E0 I is here unit vector. It means the direction of the electric field is towards x-axis. I means unit vector again towards x-axis. If the electric potential at x equal to 0, then the value of electric potential x equal to plus x will be. There you see the for a uniform electric field. The electric field is uniformly. It is in x direction. X, Y, Z. X, Y, Z. So electric field is in x direction, in the directions. At x equal to 0, it is 0. Then the value of electric potential at x equal to plus x, something here. So this would be, as it is varying with the distance is 0. So definitely the potential difference in we know the potential difference V equal to minus of E dot dr, integration of, this is the formula, potential difference, you can say delta V equal to this. So delta V, if I integrate this with V, and it will be from 0 to x, if it is x distance from 0 to x, so it would be E is constant come out, dr means it will be r, so line integration of dr would be here. Now it should be like this, r x 0 minus symbol is there, so this should be minus E x. Okay, this is the value. So answer would be, let us see the answer. Minus x is 0. Okay, because E0, it is it will be E0. This is the answer. Minus x is 0. Now come to the, let us first delete this. Now the line integral of an electric field along the circumference of a circle of radius r, drawn with the point charge q at the center will be. Options are, just a minute. Options are 1 by 4 pi epsilon naught, q by 2 epsilon naught, 0, 2 pi qr. What will be the value? The line integral of an electric field along the circumference of a circle of radius r. Okay, the line integral of an electric field along the circumference of a circle of radius r, drawn with the point charge q at the center. It is, I think, line integral of charge will be 0. No need to explain, I think. The answer would be 0. Because line integral, if you sum all these, the line integral of an electric field along the circumference of a circle of radius r, drawn with a point charge q on the center. You see, if you try to understand and doing it, suppose this is a circle and here is a point charge. So electric field here is in this direction, electric field here just opposite in the direction. So if it is positive, it will be negative. If we add this, it will be 0. Similarly, if we take here, in the opposite there will be another electric field, same value. So electric fields are like this working. So if we sum all this, it will be 0. That's why the answer is 0. So hope it is clear to you. Now let us go to the next question. A particle having mass of 1 gram and electric charge 10 to 8 coulomb travels. It is not 10 to 8, it is 10 to the power 8. This would be 10 to the power 8. By mistake, it is written as this 8 is not like this, minus 8 coulomb. Travels from a point. You can go to this yourself. Having electric potential 602 volt, having 0 potential, what would be the charge in its kinetic energy? Change in its kinetic energy. Here you see, again drawing this like this. See, suppose here it is point A, this point B. A particle of mass 1 kg, 1 gram, mass equal to 1 gram. 1 gram, so it will be in serious unit. Travels from a point A, ये A से B की तरफ जा रहा है. Having electric potential, ये जो potential difference है 600 voltage to the point B. यहाँ पे difference, potential difference at A, B equal to 600 and B में जो potential difference है VB equal to 0. So VB equal to 0. अब यहाँ से यहाँ भेजने के लिए जो जा रहा है उसका kinetic energy में क्या change होगा? Okay. So kinetic energy means, suppose this is the work done from here to here. We know work done equal to Q into, ये जा रहा है कहाँ से? B, ऐसे जा रहा है B में, VA minus VB. C. So Q into VA minus VB, VA is 600, VB is 0, and Q is equal to how much? A particle having 1 gram of electron, that is charge 10 to the power minus 8 into 600. Okay, so this is the energy. Okay, so this is the joule. So this is the energy change. So here you see 6 into now 10 to the power it is 8 na, so here you can finally write 6 into 10 to the power minus 6 joule. Joule will not be joule, it will be R because it is kg, right? It is in gram. So let us see the answer. Answer here. These are the question options. This answer. Let us go to the next question. Very important question. Here you see the area of every plate shown in the figure A and the separation between the successive plate is D. What is the capacitance between the point A and B? Okay, see options are like this. Now see मैं अभी ये लिखने के लिए ना पेन टेप यूज कर रहा हूँ तो आई थिंक थोड़ा सही नहीं आ रहा है. सो आई एम शोइंग यू हियर. यू सी जब भी ऐसे कनेक्शन दिखाएगा, देखो यहाँ पे कुछ बैटरी यूज कर रहा होगा इसे, ये दोनों टर्मिनल में बैटरी यूज कर रहा है. ओके, लाइक दिस. इफ इट इज पॉजिटिव, this positive, it is negative, so positive charge will be here, and also positive charge will be here, and for this is negative, so negative charge will be here, and for this here also the negative charge. So see, this combination become a capacitor, this combination become a capacitor. So here is two capacitor. Now we know if the distance is d between this plate and area is a, then capacitance equal to, for one plate, epsilon naught A by D. Here these two capacitors are connected in parallel, so the total capacitance would be C1 plus C2, that is they are both are equal, so E A D plus E A, it is not E, it is epsilon naught. For this epsilon naught E A by D, for this epsilon naught A by D, so this will be sum करने के बाद हो जाएगा 2 epsilon naught A by D. So this is the answer. So this is the answer. Hope you are enjoying. See the answer. One more question like this may come. So I have also show you this. I also show this to you. Now first of all, clear up all these drawings. Now you see next question. See, now the plates are connected in different manner. Here also, see, you can use the same formula, same basics I have shown you earlier. Here you see, suppose this is connected like this. This is plus, this is minus. So it will get plus, 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 plus. And this will get plus, 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 plus. This is connected to the negative, so this will get negative, 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 negative. This will get positive, 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 positive. This will get negative, 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 negative. Get negative, 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 negative. So here you see the three capacitor. One is this combination, one is this combination, one is this combination. So here we are getting three capacitors, C1, C2, and C3, and both are and all are equal. So here This kind of connection we get always. You see here, number of plates are 1, 2, 3, 4. So the number of capacitor would be n minus 1. It is 4 minus 1. It is 3. So the answer would be 3. 3 times, because epsilon naught A by D, फिर epsilon naught A by D, फिर epsilon naught A by D, they are connected in parallel. This combination can be simplified like this. Okay, so if it is C, it is equal to C, it is C, and C is equal to epsilon naught A by D. So when you add up all this, because in parallel connection, the capacitor gets added up. So this is the answer. Hope this is clear to you. Okay, so this is the answer. Now come to the next question. A particle having mass m and charge q is at rest. Rest में है charge mass m. On applying a uniform electric field E, इसमें एक इलेक्ट्रिक फील्ड E अप्लाई किया हुआ है. It start moving. ये मूव करना शुरू कर दिया. What is its kinetic energy when it travels a distance y in the direction of force? तो ये देखो, ये डायरेक्शन ऑफ फोर्स में अगर ट्रेवल कर रहा है तो उसका कितना होगा, क्या काइनेटिक एनर्जी. काइनेटिक एनर्जी का फॉर्मूला कैसे होता है जानते हो आप लोग. सपोज I'm again explaining. So suppose here it is lying the material that is mass m with charge q. Now what happen, an electric field will start moving. If electric field is in the direction, it will start moving in the directions. So force, we know, force equal to q into E. Charge is q, field is E, so this is the force. So kinetic energy will be what? Force, we know, force into distance is work done, means kinetic energy. So what is the distance? Here distance is y, so energy would be F into distance, that is q E y. Very simple, very simple, very simple. So I hope you got this. Okay, now see the answer is q E y. Very simple. Next question. A parallel plate capacitor is charged and then isolated. Now a dielectric slab is introducing it. Which of the following quantities will remain constant? I have explained this kind of questions earlier, so I no need to explain again. So answer would be electric charge. Now come to the question number 21. A moving electron approaches another electron. What will happen to the potential energy of the systems? Will remain constant, increase, decrease, or none of this? You see, this should increase. Okay, क्योंकि इलेक्ट्रॉन अप्रोच हो रहे हैं एक दूसरे का साथ. So what will happen to the potential energy of this? देखो, a moving electron approaches another electron. What will happen to the, suppose see, I think need to explain this. Suppose this is an electron, there is another electron, it is approaching this. So when it is at a distance d, तुम इसको यहाँ से इधर लेके आ रहे हो, जितना पास में आ रहे हो उतना तो उसको ये रिपील करेगा, तो कुछ ज्यादा एनर्जी लगाना पड़ेगा. इसका मीन्स इसका पोटेंशियल एनर्जी, external work done, the potential energy is equal to the negative of external work done. So to bring it here, from here जितना भी पास में लाओगे तो उसका फोर्स ज्यादा होगा ऑपोजिट में, तो एक्सटर्नल वर्क ज्यादा करना पड़ेगा. दैट मीन्स द पोटेंशियल एनर्जी विल इंक्रीज. आई थिंक क्लियर. नाउ लेट अस गो टू द नेक्स्ट क्वेश्चन. Energy of a charged capacitance is U. Now it is removed from the battery and then is connected to another identical uncharged capacitor in parallel. What will be the energy of each capacitor? Very much interesting questions. क्या होगा? So I should explain this, I think. See here. Energy of a charged capacitor is U. Suppose this is a capacitor. दिस अनदर कैपेसिटर, उसका जो एनर्जी यू है, एनर्जी ऑफ ए चार्ज कैपेसिटेंस यू एंड इट इज रिमूव फ्रॉम द बैटरी। अच्छा, ये चार्ज करने के बाद इसको रिमूव कर दिया, इसका यू एनर्जी हो गया। ओके, दिस फर्स्ट वन, फर्स्ट सपोज C1, इसको चार्ज किया गया, इसका एनर्जी यू स्टोर हुआ एंड देन बैटरी को हटा गया, देन इट इज कनेक्टेड टू अनदर आइडेंटिकल अनचार्ज इन पैरेलल, इसका भी इसके साथ ज्वाइन किया दिया गया। ये तो अनचार्ज था, कोई चार्ज क्यू था नहीं। नाउ उसमें क्या होगा, एनर्जी ईच कैपेसिटर में, देखो कोई नो, जब ये कनेक्टेड किया जाएगा तो दोनों में सपोज इसमें इसमें क्यू था, ये डिवाइड हो जाएगा क्यू बाई टू और क्यू बाई टू में। ओके, सो if it is if q by 2, if q by 2 equal to small q, then it will be q here. Okay, that means, see, for more clarification, just a minute, don't become confused. Suppose it is q by 2. Okay, then it will be more clear. Suppose it is total is q, then here after combination it will be q by 2 and here also be q by 2. Again, energy equal to how much? We know q, we know q square by c is energy. So E1 would be this and E2 would be also this, q by 2 whole square c. So upon, you can also use U1, you can also use U1 here, U2 here. Okay, and this energy will be equal. Now पहले एनर्जी था U इक्वल टू क्यू स्क्वायर बाई सी, अभी हो गया कितना, इसको कैलकुलेशन करने बाद होगा क्यू स्क्वायर बाई 4c. So this is equal to 1 by 4 times of q square by c. So the energy would be, so answer would be this. Hope it is clear to you. Okay, if you have any doubt you can mention in the comments column. Okay, so this would be the answer. Now next question, the capacitance of a variable capacitor joined with a battery of 100 volt is charged from 2 microfarad to 10 microfarad. What is the change in energy? These are the answers. So what is the answer in this question? Okay, so क्या रहेगा आंसर? 4 into the how the capacitance of a capacitor joined with battery at the voltage is charged with 2 microfarad to atom. What is the change in energy? So energy equal to, you see, you know, now I am showing this to you again. Yes, see, energy U equal to, you can write half CV square. Here you can use, see, the capacitor charge from microfarad to microfarad. What is the charge in the change in the energy? So here the voltage remain constant, so you can write this like this, half चेंज वाला चेंज होगा तो ये होगा U डैश डेल्टा U एनर्जी हाफ C 2 V square minus half C1 V square, because it's you know, चेंजिंग इट्स 2 माइक्रोफैराड से ये क्या चार्ज फ्रॉम 2 माइक्रोफैराड से 10 माइक्रोफैराड किया, इसका मतलब कैपेसिटेंस चेंज हुआ। ओके, कैपेसिटर ज्वाइन विद बैटरी है तो फ्रॉम तो माइक्रोफैराड तो माइक्रोफैराड, तो ये चेंज हुआ, कैपेसिटर चेंज हुआ, तो उसकी एनर्जी C2 और C1 है, बट वोल्टेज चेंज सेम रहा। गॉट इट? देखो, द कैपेसिटेंस ऑफ ए वेरिएबल कैपेसिटर joined with battery 100 volt is charged from एथो टू एथो, और इधर चेंज इन एनर्जी। जब ये वाला जब ये वाला कैपेसिटर हुआ तो उसका एक एनर्जी हुआ, ये वाला कैपेसिटर हुआ तो उसका भी एनर्जी हुआ, तो दोनों का डिफरेंस क्या है? ऐसे होगा। तो हाफ V is common C2 square minus C1 square. So put this value and you will get the answer. So answer will be this. So hope it is clear to you. Now I am going to the next question. Okay. So before going to the next question, I have to remove this. See. Question number 24. A uniform electric field is prevailing y direction in a certain region. The coordinates of points A, B, C are given. So which is the following alternative true? देखो, ये भी इंटरेस्टिंग है, ये भी आपको मैंने समझाना पड़ेगा। सपोज these are a uniform electric field is prevailing in, this is x direction, this is y direction, and z direction, this is the z direction. So her point is A is where? A is 0 0 point, B is 2 0 point, here is B, and C is 0 2. Okay, 0 2 means C, A B C is here 0 2. Okay, C is here. Now this is 2 0, this is 0 2, this is 0 0. Now in y direction, the electric field is in y direction. In y direction, electric field. So which of the following alternative is true? Potential. देखो, here this point and this point lying in the same line, it is equipotential line, because electric field is in the direction y direction, this is lying in the x direction, so potential here QA, the VA and VB will be same, VA and VB will be same, but VA is less than VC, VC is greater than VB. Now you see VA equal VB, it is correct. VA greater than VC, no, it is fault, because VC greater than VA. So here answer would be VA, VA greater than VC. Yes, this will be the answer. So hope this is clear to you. Hope so. This is the answer. Now next question: the capacitor of a parallel plate capacitor formed by a circular plate of diameter 4 semi is equal to the capacitance of a sphere of diameter 200 centimeters. Find the distance between the plates. Okay, these are the option. So how will you calculate this? I'm showing you the basics again. Suppose this is a sphere, a capacitor parallel plate, एक parallel plate capacitor भी इधर है, formed by a plate of diameter, a capacitor parallel plates capacitor formed by a circular plates of diameter 4 semi equal to the capacitance of the sphere. It is circular plates are circular. Okay, so this is a capacitor. See, two plates may be circular, maybe spherical, whatever, maybe a square, maybe rectangle, maybe spherical, maybe not spherical, maybe circular. These are the plates of capacitor. the diameter plates of diameter 4 is equal to the capacitance of the sphere of the diameter contact cylinder. Here question is the capacitor of a parallel plate capacitor formed by circular plates of diameter 4 semi is equal to the capacitance of the sphere of diameter 200. Find the distance between the plates. Find out the distance between the plates. D. What is the D? Here it is 200 semi. So here we can use the formula like this. You know, capacitors capacitance are equal, C1 equal to C2. So for sphere, here you see the capacitance वेरी करते एरिया के साथ. Capacitance is because C1 varies as area, C2 also varies as area. So here we can apply this. Like this, you can apply C1 equal to epsilon naught A1 or C2 equal to epsilon naught A D. D1 or C2 epsilon naught A by D2 if it is D2. Okay. Now from here you see this is spherical. This formula is for this, and as it is spherical, the C equal to would be 4 pi r square if it is radius is r. Okay. So from here, if as they are equal C1 equal to C2, so you can write sigma epsilon naught. So epsilon naught A by D equal to 4 epsilon naught 4 pi r square. So here epsilon cancel. So D would be equal to, you know, A. Here A, in place of A you can write, okay, let us simplify this again, pi r square by D equal to epsilon naught 4 pi r square. So here D would be equal to like this, pi cancel, epsilon cancel, A cancel, pi cancel. So it would be D equal to small r square by r square. Okay. If we put this, we'll get 10 to the power minus 4. So hope my writings are a little bit hazy because I am using pen tab here. So hope it is clear to you. If it is not clear, I can again explain it to you. Just by more clarification. Just a minute. This is the spherical capacitor. This is the distance is D. Here it is capital R. Okay. Here it is small r. Now in this case C2, if this is C2 capacitance, it is C1, again C1 equal to C2. C2 equal to, you can write epsilon naught A by D, which is equal to again epsilon naught pi r square by D. Here C1 equal to, for spherical, 4 pi epsilon naught, it is 4 pi area r square, 4 pi r capital R square, this capital R square epsilon. So if we equate both these, Here diameter is given, what? 200. Okay, so if the diameter is 200, here see diameter is 200. So here R would be equal to 100 semi, and here diameter is 4. Here smaller would be 2 centimeter. So if we put all this, you can get, if I divide this, this and C1 is equal, C1 equal to C2. C1 is 4 pi capital R square epsilon naught equal to D epsilon naught pi small r square by D, pi epsilon cancel. So D would be what? D equal to capital R square by इधर हो गया 4 small r square by capital R square. Okay, this is small r square. So it will be 2 small r square and 2 into 2, 4 into capital R square हो गया 100 into 100. Now this cancel, 100 into 10 to the power minus 4. Okay, minus 4 meter. So this is the answer. Now come to the point. I hope it is clear to you. Okay, this is the answer. Now question number 26. A parallel plate capacitor is charged with a battery, then spherical is separated from it. Now if the distance between the plates is increased, what will be the change? I think this question has already no. These different questions. So here they have mentioned 3 things: the change in electric field, electric charge, potential difference, and capacitance respectively. So I have already explained this, so I am showing you the answer directly. This is the answer. So I think this video will help you for your exam, monthly exams. So if it is really, you feel good, you can share this video with your friends so that they can also get the benefit out of it. And thank you all for remaining with me all these durations. So please subscribe my channel so that you will get the notifications whenever I upload any video. आपको ये मिल जाएगा notifications. So for today, thank you. Bye bye. I'll see you in the next video.